Welcome to Brain Vision.
For this question, it says to look at figure 44, where we have a circular conducting ring of a radius r connected to two exterior straight wires. So the current splits into unequal portions, all shown while passing through the ring, and we want to figure out the magnetic field B at the center of the ring. So the upper part, I call I sub u, is equal to 0.65 times the current I. The lower part, I sub L, is 0.35 times the current I. Okay, so the magnetic field due to the upper half of the center of the ring is equal to half times of the magnetic field at the center of the ring. So the upper part is half of the total magnetic field and the lower part is half of the total magnetic field. So we can say that B sub U for upper magnetic field is equal to 1/2 the total magnetic field at the center, B. So this is equal to 1/2 times, we have mu naught times, for the upper part, we have I sub u for upper, divided by 2 times the radius r. Okay, well, we know I sub u is 0.65 I, so what we have is 0.65 mu naught times I, and then divided by 2 times 2r, or in other words, 4r. Okay, now we can do the same thing for the lower part, B sub L, and this is just going to also be 1/2 times the magnetic field B, but this is going to be equal to 1/2 times mu naught times the I from the lower part, I sub L, divided by 2r. Okay, so this is going to be equal to 0.35 mu naught times I divided by 4r. Okay, so then the total magnetic field is just going to be the upper minus the lower. The reason it's minus is because these magnetic fields are working in opposite directions, right? If you curl the top or curl the bottom, they're going to be facing different directions. Again, you can use your right hand rule where you point your thumb, or you curl your fingers in the direction of the current, and you check to see which direction your thumb is pointing, and that's the direction of the magnetic field. So if you curl your fingers around the top loop, the magnetic field points into the page. If you curl your fingers around the bottom loop, the magnetic field points out of the page. So what we want to do is we want to take the total magnetic field, B, to be equal to the upper portion, B sub U, minus the lower portion, B sub L. Okay, so if we plug our values in for B sub U and B sub L that we just found, we find that it's 0.65 minus 0.35, which is 0.3 divided by 4, or in other words, 0.075. And then we still have the common factors in all of them, which is mu naught times I divided by r. So I got rid of the 4 on bottom by dividing the 0.65 minus 0.35 by 4. And I got 0.075 mu naught I divided by r. And then how about directionality? Well, since this is positive, that means the top current is larger, B sub U, and if you curl your fingers around the top current, your thumb points into the page. So this would be into the page. We can just write into page. And again, this is from the right-hand rule and the fact that this is a positive number, meaning the upper portion is larger than the lower portion. We can box that in as our solution to the question.